Imagine trying to tell your own immune system to sit down, be quiet, and stop eating your nerves like they're free snacks at a party. It sounds a little bit funny, doesn't it? But for the millions of people living with multiple sclerosis, this is not a joke. It's a daily battle inside their own bodies. The body's defenders mistakenly attack the central nervous system. This is the heart of MS. Today, we dive into one of medicine's most exciting frontiers. Will revolutionary technologies like gene therapy, CRISPR, make calming the immune system a reality? Are we on the verge of a cure, or just reading clickbait headlines? This is the question of hope versus hype. I promise clear, simple answers. Like, subscribe, and let's geek out together. MS Brain Fog allowed. The treatments available for multiple sclerosis today are, without a doubt, life-changing for many people. These drugs, disease-modifying therapies, or DMTs, have transformed the landscape of MS care over the past few decades. Their primary job is to act like a referee in a chaotic boxing match, trying to calm down an overactive immune system. They work to reduce how often relapses happen and how severe those relapses are. By slowing down the formation of new lesions, these medications can help slow the overall progression of the disease. That's true for a significant number of patients. This is a monumental achievement. These drugs give people more time, more stability, and more good days than they would have had otherwise. However, and this is a big however, these drugs are not a cure. They're playing defense, not offense. They hold the line, but they don't fix damage already done. The scars left by past immune attacks, the damaged myelin, the lost nerve fibers are not repaired by these medications. So even on the most effective DMTs, disability can still slowly accumulate, especially in progressive MS. It's like a great firefighter who can put out new fires but can't rebuild the burned parts of the house. So, what exactly is gene therapy? Let's break it down in the simplest terms possible. Think of your body as a massive library. Each cell has its own copy of the main instruction book, your DNA. In diseases like MS, some instructions can misdirect the immune system to attack. Gene therapy aims to go into that library and add a new, better page. It doesn't necessarily remove the old, faulty page. It provides a new, correct set of instructions for the cell. Essentially, it's a way to deliver a new gene genetic information into cells to help them produce a protein or to perform a function that fights the disease. It's like uploading a software patch for your cells. In MS, scientists see 3 clear ways gene therapy could be a game changer. First, protect the nerves themselves. Introduce a gene that tells nerve cells to make more protective protein, making them more resilient. Second, actively promote repair. Add genes that push stem cells to become oligodendrocytes, myelin-making cells. That helps remyelination, rebuilding insulation around nerves. Third, calm the immune system in a targeted way, teaching it to see myelin as friend, not foe. There have been early, promising wins in animal MS models. Studies show delivering specific genes can enhance remyelination in mice and lead to better functional recovery. But we must be realistic about major challenges. The biggest hurdle, delivery. If a safe gene therapy could repair myelin but carried unknown long-term risks, would you consider it? Let us know your thoughts in the comments. The concept of gene therapy is elegant and powerful, but its success hinges on one deceptively simple-sounding task delivery. This is often called the delivery problem, the biggest bottleneck in translating genetic medicine from lab to clinic. It's not enough to have the perfect genetic message. You need a reliable postal service. For MS, the target addresses are cells within the central nervous system, the brain, the spinal cord, which are notoriously difficult to reach. The blood-brain barrier is a selective bouncer. To get around this, scientists develop vectors, often adeno-associated viruses, re-engineered to be harmless. Different AAVs prefer different cell types, so choosing the right one is crucial. The immune system can neutralize vectors or spark inflammation, the last thing you want. Researchers use cloaking strategies or lipid nanoparticles to sneak cargo past defenses. Precision matters. Design the gene to switch on only in target cells, a locked package with the right key. Solving delivery is the key to unlocking gene therapy's full potential for MS and beyond. If gene therapy is like adding a new page to the instruction book, then CRISPR is like having a microscopic editor with a pair of molecular scissors and a tube of glue. CRISPR, which stands for Clustered Regularly Interspaced Short Palindromic Repeats, is a revolutionary gene editing tool that allows incredibly precise changes. Think of it this way: your DNA is a massive sentence written with billions of letters. CRISPR can be programmed to find a specific word or even a single misspelled letter within that sentence, cut it out, and either leave it blank or replace it with the correct spelling. It's a find and replace function for our genetic code. This tech was adapted from a natural defense system found in bacteria, which use it to chop up the DNA of invading viruses. Scientists harnessed it as a two-part tool: a guide RNA that acts like GPS, and an enzyme, often Cas9, which is the scissors that makes the cut. Directly editing the source code opens a new realm of therapies. It's less about adding new instructions and more about correcting the original ones, which could be a more permanent and powerful solution. Show CRISPR, like a hairstylist, fixing split ends, girl. Your myelin is a mess. On a serious note, the biggest technical challenge is off-target effects. An unintended SNP could disrupt an important gene. The CRISPR promise: 3 ways to rewrite MS. The first approach involves targeting genetic risk factors associated with MS. We know there are over 200 gene variants that slightly increase risk, many tied to immune function. CRISPR could correct these variants in immune cells, dialing down predisposition. Second, remove or deactivate inflammatory signals, cut the alarm wires. Or edit receptors so cells can no longer hear the alarm bells. Third, reprogram cells into living medicines. For example, engineer T cells to produce neurotrophic factors that protect and promote growth. Return to the body, they home to damage and release healing factors. All current MS work is somatic cell editing. Germline editing is broadly opposed due to heritable risks. Would you be more comfortable with a therapy that adds a new gene therapy, or one that edits your existing DNA CRISPR? Tell us in the comments. Hope versus hype, a reality check on the timeline, and the price tag. It's easy to imagine a cure is around the corner. This is where we breathe and stay honest. From lab idea to approved treatment is long and expensive. Typical new drug timelines are 10 to 15 years, and for gene or CRISPR therapy, possibly longer. Preclinical phase 1 safety. Phase 2 signals of efficacy. Phase 3 confirm efficacy, rare side effects. What works in mice can fail in humans. Early gene therapies have million-dollar price tags due to complexity in manufacturing. Access will be limited at first, raising equity and coverage questions. We're not at the finish line, but we're on a credible path. Science is real and accelerating with better tools and funding. Be hopeful and patient. These are likely decade after next therapies, not tomorrow's. What can you do right now? Practical steps for the patient and advocate. Follow trusted sources. Avoid miracle cure headlines. Turn to reputable organizations and academic centers. Subscribe for vetted updates. Look for plain language webinars and articles. Check clinicaltrials.gov to see recruiting studies. Consider trials or join anonymized registries to help researchers understand MS. Advocate for funding through groups like the NIH. Support walks, runs, and bike rides. Share your story. Small actions multiplied by millions create powerful change. We began this journey with a big question. When it comes to CRISPR and gene therapy for MS, are we dealing with real hope or just overblown hype? After exploring the science, the promise, and the significant hurdles, the most honest answer is this: it is a hopeful maybe. We are standing at the dawn of a new era in medicine, where we can contemplate not just managing multiple sclerosis, but fundamentally rewriting it at the biological level, protect nerves from further damage, command the body to repair its own myelin, re-educate the immune system into a state of lasting peace, tangible goals in labs across the globe. This is not the hype of a quick fix or a miracle cure that will be available next year. From bench to bedside is a marathon, not a sprint. Delivery, off-target effects, accessibility. But the hope is real. We are moving with unprecedented speed towards stopping MS and perhaps even reversing some damage. Before we close, I have a quick request. If this gave you hope, even cautious hope, hit like, subscribe, and share.